Good day everyone. Welcome to today's session on program analysis. It is an important component in ensuring the correctness, reliability and performance of software systems. And I am Soumya from the Department of Artificial Intelligence and Data Science, and this topic falls under the broader scope of object-oriented software engineering. Let's begin by understanding the theoretical foundation and practical importance of analyzing the programs both during the development and execution. What is program analysis? Program analysis refers to the systematic process of examining the source code to identify the errors, inefficiencies, vulnerabilities, and areas for optimization. The analysis can be static, which involves reviewing the code without any execution, or dynamic, which entails the monitoring behavior during the execution. These two approaches serve the distinct yet complementary purposes. First one is static analysis. It checks the code structure, syntax, and the logical constructs pre-runtime. And the second one is dynamic analysis. It evaluates the runtime behavior like memory usage, exceptions, or performance. The goal is to make the software of correct and aligned with the specific specifications. And second one is clean. It free from unnecessary or redundant constructs. Then safe. It's secure and error free. Then efficient in the sense of optimized in terms of performance. This is foundational to writing robust and maintainable code. Then types of program analysis. Let's delve into the static program analysis. This method inspects the source code without executing it. It involves the tools that parse code and perform checks like syntax errors and unused variables and type mismatches and dead code. For example, consider x is equal to 20 and y is equal to 20. Then we will print the x. Here y is never used here. A static analyzer would want variable y assigned but never used here. This helps to clean up the unnecessary code and prevents the potential confusion or errors. Compilers, linters, and IDEs are commonly include static analysis capabilities. It is especially useful in large code bases where manual code reviews become impractical here. Then dynamic program analysis. In contrast, dynamic program analysis involves the executing the code and observing in behavior and real time. It focuses on detecting the runtime errors and monitoring the memory usage and measuring the execution time, testing the input or output behavior. For example of a is equal to 20 and b is equal to 0, print of a divided by p. Here raises the division by 0 error. While static analysis may not catch this, dynamic analysis triggers the error during the execution and enabling the developers to handle the exceptions effectively. This is important in unit testing, load testing, and performance profiling, where behavior under various input is evaluated to ensure the software resilience. Then example for both types. Let's consider a unified scenario. Suppose a function is meant to process users data. Here static analysis might reveal that a declared variable is never used here, while dynamic analysis might expose a crash if invalid input is provided here. Here for example of we use the temporary variable used here is 5 and return 100. Here static analysis flags the unused variable like temporary variable, and dynamic analysis, when data is equal to 0, it raises a division by 0 error. Using both techniques together provides a comprehensive view, catching both syntactic and runtime issues. Then tools used for program analysis. A range of tools exist to automate the program analysis. First one is static analysis tool. PyLint and Flake 8 is used for Python, and SLint is used for JavaScript, and FindBugs and CheckStyle is used for Java, and SonarQube is used for multi-language support. These tools enforce the coding standards and identify the code smells and suggest the improvements. Then dynamic analysis tool. Valgrind is used for memory analysis in C or C++. Then JUnit and Makito is used for Java testing frameworks. Then Selenium, it's used for browser automation for UI testing. Then Profilers like gprof and PySpy, it monitors the execution time and function call. In professional environment, these tools are integrated into continuous integration and continuous deployment pipelines to ensure the continuous verification of code quality. Then benefits of program analysis. To summarize, program analysis offers multiple strategic benefits. Early error detection. Bugs caught at compiled runtime reduces the debugging time and cost. Then quality assurance. Ensures the code adheres to best practices and design principles. Then security helps to identify the vulnerabilities like buffer overflows or injection flaws. Then performance optimization reveals the inefficiencies and bottlenecks. Then last one is maintainability. Cleaner code is easier to understand, refactor and scale. In industries like banking, healthcare and automotive, where software failure can be critical, program analysis is not optional, it's essential. And this concludes our discussion on program analysis. I hope you have gained a deeper understanding of the techniques and their real world application. I encourage you to try out both static and dynamic tools on your own projects to appreciate their impact firsthand. Thank you.